Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at ions and ionic compounds. So hopefully by the end of this lesson today you're going to be able to describe how ions form and then how ionic compounds form, as well as a couple of key things about them. To start off though, we've got 4 questions based around our previous lesson, so have a go at answering these 4 questions in your books for me. So I'm going to give you about 3 minutes to do this today. Let's check these answers then to make sure we've got them right. So as always, tick any you've got right so that we can get you a score at the end. So in terms of our periods, those are the horizontal rows on the periodic table. Question 2, the groups are the vertical columns on the periodic table. For question 3, we've got a range of marks available. So you get a mark if you said that the element is in group 2. You get a mark if you said it's in period 3. You get a mark if you said it has 12 electrons. You get a mark if you said it's got the atomic number of 12. And a mark if you just named it as magnesium. And then finally for number 4, for our electronic configuration for silicon, then I've given you the diagram there. 2 electrons on the first shell, 8 on the second, and 4 on the third. And don't forget we should also have the numbers 2.8.4, so you get 1 tick for the diagram and 1 tick for the electronic configuration written as 2.8.4. So mark your work for me and then add it up. We've got a total of 9 today, so give yourself a score out of 9. Okay, so what we're going to be looking at in today's lesson are ions. Now this is again something I'm hoping that you've touched on lower down in Key Stage 3. But what we hopefully remember when we talk about an ion, we're talking about a charged particle. So atoms are neutral, they have no overall charge, whereas an ion does have a charge. And they will either be positive or negative. Now, the reason that we have an ion is because that atom, with its no overall charge, has either gained or lost electrons. And in gaining or losing electrons, it then confers that either positive or negative charge. Now, hopefully we remember that metal atoms are on the far left-hand side of our periodic table, and those ones are in things like group 1, group 2, group 3, and so forth. And what they're going to do is they're going to lose electrons when the ion forms. So because they're losing electrons, that means there are more protons than there are electrons in its structure, so they have an overall positive charge. Whereas the non-metal atoms on the right-hand side of the periodic table do the opposite. They're going to gain electrons, and so therefore they've got a negative overall charge because there are more electrons in their structure than there are the positive protons. So what I'd like you to have a go at doing is finishing off those 4 sentences for me. So I'm going to give you just another 2.5 minutes to do that. Let's double check to make sure we got all those right. So an ion is a charged particle. It's formed when an atom gains or loses electrons. Metal atoms form positive ions, and non-metal atoms form negative ions. So give yourself a tick for each one of those you got right, and then give yourself a total score out of 4 for that one. Obviously, any you didn't get right, make sure you've got the correct ending written for each of those sentences. So what we've already said is that these ions are going to form when either electrons are gained or lost. So we know that's either going to make them positive or negative. But the other fact is that the number of electrons that they either gain or lose tells us the number of positive or negative charges that we have on that ion. So for an atom that's going to gain 2 electrons, then the ion of that atom would be a 2- charge. Whereas if it only loses 1 electron, then it will just have a single positive charge on that ion. So make sure you've got that sentence written down. What you've got on the screen now then are 7 different atoms. What I'd like you to do is write down the charge for the ions for each one. So if I give you the first one as an example, because sodium, Na, is in group 1, then it's going to lose 1 electron, so the charge on the ion would be Na+, and the little plus, the charge is always going the top right of our formula. So see if you can have a go at the other 6. I'm going to give you about 2 minutes to have a go at this, and you are of course allowed to use a periodic table, so if you haven't got one handy, hit pause and then go grab one quick off the internet. Okay, so number 1 we've already done, Na+. Number 2, chlorine, that's in group 7, so therefore it's going to gain 1 electron and becomes Cl-. Remember the minus in the top right. Number 3, fluorine becomes F- because also in group 7 gains 1 electron. Lithium is in group 1, so it loses 1 electron to become Li+. Magnesium is in group 2, so it loses 2 electrons to become Mg2+. Calcium, also group 2, loses 2 electrons, becomes Ca2+. And then finally, oxygen is in group 6, so it gains 2 electrons to become O2-. So give yourself a score out of 6. You don't get the bonus point for the one I told you earlier on. So questions 2 to 7 are the ones you get the marks for. Score out of 6. One of the things that we need to be able to do is draw dot and cross diagrams to show different types of bonding. Now, before we can really get too far with this, we need to understand how to draw electron diagrams to show the structure of these ions. So I'm going to take you through lithium first of all. So when we're actually going to write our electronic diagram to show lithium forming an ion, then what we need to do is obviously look up how many electrons lithium has. So hopefully we remember that lithium has 3 electrons. So 2 go on the innermost shell and then 1 on the next. So that's our lithium. Now that, remember, is lithium as an atom, because we've got 3 electrons here, and in the nucleus, which we've not drawn, there would be 3 protons. Now that lithium is going to then form the lithium ion. So what we still have are the 2 electrons on that inner shell, but that one on the outer shell is actually going to be lost. So what happens is this electron here is lost, which means that we have formed our ion, and it has a single positive charge. So we've got Li+, because what we've got here now are 2 electrons, and we still have the 3 protons in the nucleus. So what we have are 3 protons, which have got a positive charge, but only 2 electrons with the negative charge. So that means that obviously 2 will be cancelled out by the 2 electrons, but we're still left with a single positive charge there. So what we do is we put these square brackets around our diagram, and then we put the charge in the top right corner. So that's how we work out our lithium ion and draw the electron diagram to show it. So we've seen how we're going to form these positive ions. Now let's have a look at how we would draw one of these electron diagrams for a negative ion. This time we're going to have a look at chlorine. If we now consider chlorine, then chlorine, again we're going to do the atom first of all. So 2 on the first shell, then we've got our 8 on the next, and what we then have on our third shell are 7 electrons. And we know it's got 7 electrons because it's in group 7, so we know there must be 7 electrons there. So again, that is the chlorine atom. Now what's going to happen in this case to make the chlorine ion is we're going to gain an electron. So we still have the 2 on our inner shell, we still have our 8 on the next shell, and then on that third shell we still have the 7 electrons that we started with, but we're also going to gain an extra electron, and we draw it as a dot because these are what we call dot and cross diagrams. And then what we do is we put our square brackets around it, and this time because we've gained an electron, there's an extra negative charge, so in this case the chlorine ion is going to have a single negative charge, so Cl-. So you've seen how we do the positive and the negative ion electron diagrams. So what I'd like you to do is draw electron diagrams to show the ions that we form for the 5 atoms on your screen now. So I'm going to give you 5 minutes to have a go at this. let's mark those then. So on the screen you can see the correct diagrams, drawn a bit poorly in some cases, my apologies. So we've got fluorine in the top left. It's gained 1 electron, which we've got to draw as that dot, remember, and it's got a single negative charge. Lithium, single positive charge. Magnesium, 2 positive charges. Calcium, 2 positive charges. And then oxygen, 2 negative charges, making sure that those 2 additional electrons are the opposite to the ones they started with. So if you use dots, they need to be crosses. If you started off with crosses, then the extra 2 need to be dots. So give yourself a score out of 5 for those for me. So I'm going to leave those up just for another 10 seconds, just in case you want to make any corrections. So now we know how to draw electron diagrams for ions, and we can also describe how ions form. We need to know about the first type of compound, which is an ionic compound. So this is where 2 ions have come together and joined. Now what we find is that these ionic compounds are held together by something called an ionic bond. Now what we're going to find is that ionic bonds form when we've got a positive ion and a negative ion, or more than one positive and negative ion. But the key thing here is that you've got to have positive and negative ions. So what we're going to see is that when we've got a metal reacting with a non-metal, then we're going to form an ionic bond. So ionic bonds form between a metal and a non-metal. I think it's probably easier if we have a little look to see what happens first of all. So what we're going to do is have a look at the reaction with sodium and chlorine and how we draw the dot and cross diagram to show this formation of a bond. So when it comes to actually drawing a diagram to show how our 2 ions are going to join together, then we've got 2 here, sodium and chlorine. So let's start off by drawing our sodium. So sodium has 2 electrons on the inner shell. Then we've got our 8 electrons on the next, and then on our final shell we've got 1. So obviously we've got 2.8.1, that is our sodium. And if we do the same for our chlorine, but this time notice we're going to use dots. So when it comes to doing dot and cross diagrams to show bonding, one element must be using dots and the other must be using crosses. It's kind of given in the name. It's called a dot and cross diagram for a reason, not a cross and cross or a dot and dot diagram. It is a dot and cross diagram. So what we're then going to do is just fill out, there we go. So 2.8.7. So there's our sodium atom, there's our chlorine atom. Now what's going to happen is these are going to form ions. And the way that that happens is that this electron here is going to be transferred to the chlorine. So what we then see happening in terms of the ions is we've got our sodium, which has still got the 2 electrons on the innermost shell, and then our next shell, that's a terrible circle, is going to have the 8 electrons, put it into the square brackets, and give it the positive charge. Then we do our chloride ion, and again remember these were the dots, so 2 on the first shell, then we've got our 8 on the next shell, and then our final shell we have 7 electrons that were originally from the chlorine, so they're the dots, and then that electron there from the sodium we put it in but we keep it as a cross. And then what we do, put it in the square brackets, give it a negative, and then because we've got 1 positive charge here, 1 negative charge here, they cancel out, and what we've actually made is our formula NaCl, sodium chloride. Okay, your turn. There's 2 for you to have a go at, magnesium oxide and sodium oxide. So draw out your electron diagrams using dots and crosses, then write the chemical formula that we make for those compounds. So I'm going to give you about 5 minutes to have a go. Okay, let's check those answers then. So our first one, magnesium oxide. So we start off with our magnesium. Now magnesium has 12 electrons, so 2 go on our first shell, 8 go on the next, and that leaves us with our outer shell, oh dear, with 2 electrons. And then for our oxygen, then that's got 8 electrons, so again remember to do these as dots, so 2 on the first shell, and then we've got 6 on the next. So what we then see happening is these 2 electrons are going to be transferred to the oxygen, so that what we then form is our magnesium. First shell stays the same, got our 8 electrons on what now becomes the outer shell, put it into the square brackets, and because we've transferred 2 electrons across, because there's 2 in the outer shell there, that has a 2+ charge. Then for our oxygen, what we're going to do is redraw it as we have it. So there's 6 electrons that were originally with the oxygen, and then the 2 that came from the magnesium we do as the crosses into the square brackets, and that has a 2- charge. So when we're actually looking for the formula, it is MgO, because 2 positives, 2 negatives, so 1 magnesium ion joins to 1 oxide ion because they cancel out. The other one we needed to do was sodium and oxygen. Now sodium has got 11 electrons, so let's just quickly draw that one. 1 in the outer shell. And oxygen, as we've already said, has got 8, so we quickly redraw that one. There we go. Now, what we're going to see in this case is this electron here is still going to be transferred, but that would only obviously give it 7 electrons. So what we're actually going to see is that there are going to be 2 of the sodiums. So what we then end up with are sodium here, and we just redraw this to form our ion. Put our square brackets around it, and a plus. And I'm going to draw this out so you can actually see why we've got these. Now, we're going to have 2 of the sodiums here, because each sodium has a single positive. But remember, when we look at our oxygen, when that becomes an ion, then it's going to be gaining 2 electrons. So that means 1 electron came from this sodium, 1 electron came from that sodium, and our oxygen, when it's in an ion, has a 2 negative charge. So what we need is actually 2 sodiums, each with a single positive charge, to join with 1 oxygen. So the formula for that is Na2O, because every time we form these compounds, the positive charges must cancel out the negative charges. Now, what we actually find then is when we're talking about some of these compounds, like sodium chloride, it's not just 1 sodium joining to 1 chlorine. What we actually have is a structure like we see in the diagram on your screen. So what I'd like to do first of all is look at that diagram and describe the structure of sodium chloride for me. Now, when you described it, you probably said something along the lines of there are alternating positive and negative ions, or the positive ions are surrounded by negative ions. Now, the reason we get that is because we formed a structure called a giant ionic lattice. And this is an important phrase to know. Now, it's called a giant ionic lattice because there's large numbers of those different ions joined together. Ionic because it contains ions, and lattice just tells us that it's a regular arrangement of those ions, so the positive, negative, and so on. All of those ions that we can see are held in place by ionic bonds. Now, those ionic bonds, as we've said, form between the positive and the negative ions, and what they actually are is this strong electrostatic force of attraction between the oppositely charged ions. So between each positive and negative ion we can see in that structure, we have an ionic bond, that strong electrostatic force of attraction. What I'd like to do is write down those 3 sentences and then see if you can just explain what giant ionic lattice means. So explain what the word giant represents, what the word ionic means, and what the word lattice means. Last thing for today then is the plenary. So if you've got a target grade up to a grade 5, it's the 2 columns on the left. Those who are target grades over a grade 5, it's the 2 columns on the right. So I'm going to leave these up for about another 4 minutes today, but obviously you can pause the video and take as long as you need.